Hello everyone, and thanks for tuning into my presentation for the HTMA Summit. I'm John Bumpus of mineralbalancing.org, an educator at the Mineral Balancing Academy. I have a bachelor degree in holistic health sciences, and I'm currently pursuing a combined master's and PhD degree in natural medicine at the Quantum University of Integrative Medicine. I'm also a senior fellow of the Society of Natural Therapists and Researchers, or SNTR, here in Australia. I chose to talk with you today about calcium because I'm very passionate about using this nutrient in my practice. I won't be talking about the conventional topics with calcium, such as its roles with copper or magnesium, since much of this will be discussed at length either in this summit or it's also discussed quite often in the HTMA community. Now, I used to avoid calcium at all costs, believing that this was ideal for bone health. I avoided dairy and focused mostly on magnesium and a plant-based diet that was nearly vegan, with the exception of egg and butter. But life takes many twists and turns, and unfortunately, I had a spinal injury at the age of 21, which left me in chronic pain and an inability to walk. I tried everything I could to improve my situation, but eventually I ended up in a state of burnout, and I started to suffer from calcium buildup in my muscles, which were a lot like barnacles, and I could feel them if I were to palpate the muscle. Now, chronic pain is exhausting, and I know this firsthand. I was quite reluctant to change, but inevitably I learned that if I was really unhappy with where I was, then I would have to change to create a possibility of something different to come about. And this is where HTMA came in for me. And I can honestly say that while I moved towards a more omnivorous diet quite slowly, incorporating calcium supplementation is really what moved the needle for me. Now, I regularly see others also using calcium to improve their health in my practice. But still, there's a lot of fear and myths that circulate within the health-oriented communities, especially in the HTMA community, regarding calcium. My intention today is to help demystify many of the paradoxes by uncovering how these occur in the first place. So we have a lot to cover today, so please bear with me. I'm sure that you'll learn something. In this presentation, we're going to be covering a little bit about calcification. We're going to talk about calcium metabolism, which you might think is a little bit boring, but it's really important, I promise. We will touch on the three main hormones which regulate calcium metabolism. I'm going to talk about the importance of obtaining the RDI or the RDA, and then going beyond that into balancing the calcium to phosphorus ratios of the diet. We're also going to talk about the absorption of calcium and osteoporosis according to an HTMA. And I'm also going to bring up a little bit of this new concept of using different forms of calcium for different metabolic rates according to the person's hair tissue mineral analysis. Now, due to calcium's presence in calcified tissue, which is a major cause of chronic health conditions, a large portion of natural practitioners logically come to the conclusion that calcium supplements contribute to calcification. And this is why I refer to calcium as the black sheep of HTMA. Speaking of black sheep, calcium is not the only one. Others include vitamin D and copper. And these nutrients are also considered black sheep, mostly because of their connections or their relationships with calcium. They both raise calcium on a hair tissue mineral analysis, and since 80% of people already have an elevated calcium, then it seems quite logical to avoid copper, vitamin D, as well as calcium, since all of these could potentially contribute to the elevations of calcium that we see on the HTMAs, and thus calcification. But is this really the solution? Is calcium all bad? And should we really avoid it? My personal and clinical experience tells me no. We shouldn't avoid calcium. and that it's not as bad as it's been made out to be. Those that specialize in HTMA and mineral balancing have a great appreciation for minerals, so I know that I'm preaching to the converted when I say that minerals are very important to support and promote health in general, let alone optimal health. Now, we often hear about people focusing on toxic or heavy metals, or how these are a major cause of disease. And let's be honest, that's true to a certain degree. But calcium also embodies this idea that we need nutrient minerals, and if we have too much of them, even they can be toxic or debilitating. Since we acknowledge that all minerals can be a cause for various health conditions, even the nutrients, I think that there's no other element that better reflects the principles of hair tissue mineral analysis and mineral balancing than calcium, because it encompasses the balancing act that's involved with interpretation and using nutrient therapies to help correct the results on the HTMA. Now, calcium itself is not the issue. It's calcium in the wrong places that causes many health conditions. Calcification is essentially a biological form of rusting that occurs when extracellular calcium becomes intracellular. And it's the result of accumulating calcium salts in the body tissues. Now, calcium and sodium are primarily extracellular minerals, meaning they're meant to be primarily outside of the cell, while magnesium and potassium are meant to be primarily inside of the cell because they're intracellular minerals. When cells are excited, stressed, or de-energized, they lose intracellular magnesium and potassium, and they begin to take up abnormal amounts of sodium and calcium. The mitochondria, the energy powerhouses of our cells, can bind a certain amount of calcium during stress, but calcium can accumulate to a point where it eventually inactivates the mitochondria, and it forces the cell to use this less efficient energy production called glycolysis, and this eventually produces excess of lactic acid. Now, ultimately, abnormal calcification begins in our cells and in the mitochondria. Now, if we remember back to biology class in high school, we can remember that cells make up tissues, and tissues make up, when they're conglomerate, they make up organs and glands. And when our organs and glands work together, we make up humans, right? Now, all cell death is characterized by an abnormal, excessive increase of intracellular calcium. So it's the final and common path of all cell disease and cell death. So when there's excess calcium in the cells, it can be quite damaging to our health as a whole, especially if it accumulates into tissues and then organs, and then it affects organ systems and drastically impacts your health. Now, calcification is the major link between all age-related diseases. Thus, it's implicated in many chronic diseases that are associated with aging, such as hypertension or cataracts, arteriosclerosis, diabetes, even dementia, just to name a few. Now, currently, calcium is one of the most feared minerals to supplement, mostly because of this process of calcification. Those who know about the involvement of calcium and calcification in aging and stress and degeneration generally suggest eating a low calcium diet to minimize the buildup. But what they don't realize is that calcium is part of the solution. When there is a dietary deficiency, it actually intensifies the process of calcification of the soft tissues. And I'll explain how this occurs a little later in this presentation. Now, it's quite common in the HTMA communities to bring up copper when it comes to calcification, since, as I said earlier, copper raises calcium levels and copper burdens are a major cause for an elevated calcium on an HTMA. Copper becomes biounavailable when the adrenal and liver are not functioning in a healthy manner. I won't be getting into this aspect today, although I definitely recognize it as a factor to consider as well when it comes to calcification. Now, as you follow me through this presentation, I will demystify the importance of calcium and start to unveil many of the paradoxes and myths as only being superficial and, at best, artifacts of illusion. Now, there's quite a few paradoxes surrounding calcium. The major paradox with calcium is that, at least the one that brings up quite a bit of controversy, is that when our bones start to deplete of calcium, other tissues, such as soft tissues, begin to calcify. Tissues, such as the muscles, organs, or glands, increasing calcium when there is a deficiency of calcium. Another interesting phenomenon is that when there is a dietary deficiency, blood calcium rises. Thus, it can also seem quite odd, especially if there's a lack of this nutrient present. Another paradox is that all minerals are susceptible to nutrient interrelationships, and calcium is no exception, especially when you consider it with magnesium. As antagonistic nutrients, calcium and magnesium can compete or even block each other's metabolic functions and even the absorption of each other. Yet the signs and symptoms of deficiency and the excess are quite similar. For example, a calcium deficiency symptom is muscle cramps, and this is also a symptom of magnesium deficiency. Now, in HTMA, what this means is basically that the symptoms of a high or a low calcium to magnesium ratio can be very much the same. So there's muscle spasms caused by excess calcium, and there's muscle spasms caused by excess magnesium. Now, before we go into these paradoxes, I'd like to remind everyone a little bit about the importance of calcium in the body. Now, calcium is one of the most studied elements in science, whether it's in the living environment, the biosphere, or in biology in general with plants, fungi, and animals. Calcium is one of the minerals that takes the leading role of importance. Now, did you know that calcium is the 5th most abundant element in the Earth's crust? And in the body, calcium is the 5th most abundant element and the most abundant metal in the body. There's about 1 kilogram or 2.2 pounds of calcium that's present in the adult body. Now, the vast majority of the total body calcium, about 99%, is found in the skeleton as a complex of calcium and phosphate. It's primarily known as hydroxyapatite, which is responsible for the material properties of bone. Most of it's found in our bones and in our teeth. And, when you think about that weight, that's quite a lot compared to the other minerals that are in the body. So next to carbon, hydrogen, oxygen, and nitrogen, the lion's share of the human body is actually made up of calcium. Now, I wonder if this is just a coincidence, but the more I learn about nature, the more I'm in awe of the patterns of as above and so below. I don't feel it's a coincidence that we have so much of it in our bodies. And if it were so dangerous to consume, why would calcium be so prevalent in our environment and in our body? It just doesn't make sense to me. So I knew there was something more to calcium. Now, calcium is an essential mineral, and it's required for the proper functioning of many intracellular and extracellular processes, things like muscle contraction, nerve conduction, the beating of your heart, hormone release, blood coagulation, energy production, and the maintenance of the immune system or the immune function. Calcium also plays an important role for intracellular signaling and is involved in the regulation of many enzymes. Now I'm going to spend a little bit of time talking about the science of calcium metabolism to further demystify the seeming paradoxes that I've mentioned so far. This diagram on the slide here shows how calcium is distributed throughout the body. At the top, as I mentioned earlier, the total body calcium of about 1 kilogram. Almost all of it, 99% of it, is found in our bones. Now the remaining 1% is distributed between soft tissue cells and extracellular fluid. This is the interstitial fluid and blood plasma. Approximately 350 milligrams of calcium circulates in the blood plasma, and of this 350 milligrams, around 40% is bound to proteins, albumin or globulins, things of this nature. And 10% is in a complex with other anions such as bicarbonate or lactate or phosphate, this sort of thing. Now the remainder, that 50% that circulates through the blood, is what's called free ionized plasma calcium. It's a divalent calcium, so it's got a +2 charge. In this presentation, I'm going to refer to this primarily as just blood calcium because I kind of want to reduce the word salad and keep things simple. So the 3 fractions of calcium that are present in the blood are in an equilibrium, but it's most important to note that it's only the ionized calcium fraction that's physiologically active. Now I'm showing you this information because it actually is quite important on an HTMA and why we have an elevated calcium on hair tests, and I'll get to that shortly. So let's talk a little bit about calcium metabolism. So since calcium is so abundant in the body and in our environment, we have adapted feedback mechanisms which help keep our calcium balance in check. Now the principal hormones that are involved in calcium metabolism are the parathyroid hormone, which PTH, calcitriol, which is the active metabolite of vitamin D, and something called calcitonin, which is a thyroid hormone that lowers calcium in the blood. Let's start with parathyroid hormone and calcitriol, which is also known as vitamin D. A PTH, or parathyroid hormone, is produced in and secreted from the parathyroid glands, which are 4 tiny rice grain sized glands on the thyroid. I often talk about the thyroid, how it looks like a butterfly, and the parathyroid glands are like little jewels on the butterfly's wings. When calcium concentration drops in the blood, there's calcium sensing receptors on the parathyroid gland, and when they sense this drop in the blood, they release this hormone called parathyroid hormone. The target area for parathyroid hormone is the bones and the kidneys. Now parathyroid hormone promotes something called resorption of bone, which is basically just a fancy way of saying that it pulls calcium from the bones to the blood. And it does this through its action on osteoclasts, which are cells that take calcium from the bone. The parathyroid hormone also goes through the blood to the kidneys, where it tells the kidneys to reabsorb calcium rather than excreting it through the urine. Now, parathyroid hormone essentially tells the kidneys, hey, let's recycle calcium so it's not being lost in the urine. Now, what this means is that parathyroid hormone reduces the amount of calcium in the bone and stops the urinary excretion of calcium to raise the blood level. Now, once the blood level of calcium comes back up within this normal range, parathyroid hormone secretion is stopped, or even, well, not entirely stopped, it's reduced by the parathyroid gland. Another function of parathyroid hormone is with vitamin D. And parathyroid hormone stimulates the enzymatic conversion of 25-hydroxycholecalciferol to calcitriol, which is the active form of vitamin D in the body. And just like parathyroid hormone, calcitriol is promoted by a reduced calcium blood level, and it's blocked by elevated calcium in the blood plasma. Now, the target tissue of calcitriol is the gastrointestinal tract, where it promotes the absorption of dietary calcium. This is why you often find calcium supplements that have vitamin D present with it, because this helps increase the absorption of calcium, which can therefore increase the blood calcium level. Now, these two hormones, parathyroid hormone and calcitriol, work together to increase blood calcium levels, and they're critical for maintaining that extracellular or that blood plasma calcium level within the normal limits to help correct those low calcium levels. The effects of parathyroid hormone and calcitriol are the reason why we have this paradox regarding calcium deficiency and an increased blood calcium level. An interesting note is that, well, many people bring up magnesium's importance in regulating calcium in the body. What they often don't talk about is how parathyroid hormone can also regulate magnesium homeostasis in the body by modulating this renal reabsorption, just like it does with calcium. And I find this really interesting because people often talk about how magnesium is important for regulating calcium. But since parathyroid hormone can signal the kidney to recycle magnesium, and parathyroid hormone is released dependent on calcium, to some degree, calcium is actually really important for regulating magnesium as well. Yet another example of the expression of the synergistic properties of calcium and magnesium. Now, parathyroid hormone are helpful for raising blood calcium. Calcitonin, which is a thyroid hormone, its effects are the exact opposite. It is antagonistic to parathyroid hormone and vitamin D. So if the blood calcium level is too high, the thyroid releases calcitonin, and calcitonin works to control calcium and potassium levels. It does this by blocking the activity of the parathyroid hormone on the osteoclasts, those cells that break down bone. Remember, the osteoclasts break down the bone so that the calcium can enter the bloodstream. So when calcitonin blocks the activity of parathyroid hormone, it blocks or at least it prevents the breakdown of bone, and therefore calcitonin lessens the amount of calcium in the blood. Calcitonin also seems to decrease the amount of calcium that the kidneys can reabsorb or recycle, and this is helpful also for lowering the levels even further. Now, secretion of calcitonin is controlled directly by the blood calcium level. When the levels start to increase, the body responds with an increased amount of calcitonin, and when the calcium levels drop, so do the calcitonin levels. So just want to cover a quick summary of what we've talked about. So parathyroid hormone and vitamin D are secreted when the blood calcium is low. And when the blood calcium is high, calcitonin is secreted by the thyroid gland to oppose the effects of parathyroid hormone to lower a high blood calcium. The action of these three hormones allows calcium to stay in balance in the blood. And this is also why measuring blood calcium is not a great indication of calcium status in the body, because it's balanced through homeostatic mechanisms by depleting bone. So this is an HTMA presentation, so let's talk a little bit about the hair. The constituents of the hair, the minerals that are found on an HTMA can really only come from two different sources. They come from internal sources, things like our bloodstream, our extracellular matrix, cerebrospinal fluid, our lymphatic system, and potentially sweat, or environmental factors such as dust or a contamination. Now, it's important to keep in mind that hair is a minor excretory tissue, so we always see losses of elements in hair. The minerals in the hair are an average of what has been circulating through the blood over a period of time. Since hair is a tissue, the average amount of minerals that end up in the hair reflect what other tissues would also be receiving from the blood. And this is why hair provides important insight into the nutritional status of the body. Now, when it comes to a high level of calcium in the hair, it is because it is somewhat high in the blood. And as we recently learned in this presentation, that when a person has a high calcium in the blood, it is due to a deficiency of calcium. Parathyroid hormone is making the blood calcium high because it's pulling it from the bones. An elevated calcium is typically found also with a low potassium level, which indicates an underactive or a low thyroid function. When the thyroid function is underactive, the hormones it produces will also be underactive, such as calcitonin, which regulates a high calcium in the blood by antagonizing PTH and lowering calcium. So as a result, we will find a high normal level of calcium in the blood. The calcium in the blood becomes biounavailable and moves from an ionic state into a salt when there's low magnesium, sodium, and potassium. And as we know, according to HTMA science, that is common in slow oxidizers. So these slow oxidizers are known for having a low thyroid function and low adrenal gland activity and a very underactive hormone release. Thus, over a period of 3 to 4 months, we see an elevation of calcium. A high calcium on an HTMA is really the result of a calcium deficiency and an exhaustion stage of stress. Dr. Watts, one of the pioneers of HTMA, wrote in the Journal of Orthomolecular Medicine in 1990, confirming this by saying that when an overactivity of the parathyroid gland develops, a concomitant low thyroid is usually found, and that patients with hypothyroidism frequently have elevated parathyroid hormone levels. Now, since blood levels of calcium rise during deficiency, then it would make sense that when the parathyroids are overactive, that we'll find an elevated calcium level on an HTMA. And we find the slow oxidizers have a tendency for hyperparathyroidism and low thyroid activity. Now, on a side note, you can also see on this HTMA that the sympathetic dominance is present with the low potassium level of 4, and even though the magnesium level is in this normal reference range, there's an elevated calcium to magnesium ratio, which is also an indication for what's called a secondary hyperparathyroid state. And this is because magnesium can also lower parathyroid hormone, as well as, at least on this hair test, you can also see that there's going to be an elevated calcium to phosphorus ratio, which is indicative of a primary hyperparathyroid state. Now, when PTH is low but calcitonin's high, we will have a tendency to have low calcium levels in the blood, and then also it would reflect on the HTMA. And this is because the fast oxidizers, which are known for having that overactive thyroid function based on their calcium to potassium ratio, and they're known for excreting or at least losing calcium through their urine because they're in that alarm stage of stress. Due to their overactive excretion of calcitonin, because of that elevated thyroid, the PTH still is trying to pull calcium from the bones to balance, blood calcium, but that overactive thyroid function causes that low calcium status. So you can have someone still depleting their bones of calcium, but also have a very low calcium level on an HTMA. And this is because of a loss through the urine. Now, what this means in terms of mineral balancing is that both of these patterns, fast and slow oxidation, still require calcium. And this is true even if their calcium level is ideal, because it could be artificially raised. Since blood calcium is controlled by a sensitive homeostatic feedback loop, a normal or even ideal level of calcium on an HTMA can be a false indication of a person's true calcium status, since the level of calcium is so tightly controlled. I call this a pseudo-ideal calcium level. Now, we can also find this information on other studies, and this is just one example, showing that calcium deficiency can result in a high calcium level and depleted bone. So here's a paper by Soo-Jung Park and their colleagues, and it's titled "Hair Calcium Concentration is Associated with Calcium Intake and Bone Mineral Density." Now the aim of the study was to investigate whether hair calcium concentration was related to calcium intake and the calcium content in bone, and they did this through measuring bone mineral density. Now, depending on the concentration of hair calcium, the participants were divided into quartiles and 4 groups to compare the calcium intake and their bone mineral density. In the highest quartile, the one that ingested significantly less calcium compared to the rest, also had the highest hair calcium concentration, and they also had a significantly lower bone mineral density and T-score in the L1 to L4 vertebrae compared to the rest of the groups that were measured. And these results show that a high hair calcium concentration is associated with a low calcium intake and low bone mineral density. And as I said, this makes a lot of sense because PTH will pull calcium from the bones to raise the blood calcium level and thus put it in the hair. This also brings forth this idea that calcium can be very helpful for maintaining bone mineral density through its effects on hormones such as parathyroid hormone and calcitonin. Now, another thing to consider when assessing calcium levels via bone mineral density test is that when the body takes calcium from the bones, it can also deposit other minerals back into the bones to take the place of that calcium. And this is what I refer to on my website as the biological replacement of elements theory. But in general, lead in the bones, hair, and nail aren't really seen as harmful by modern medicine, since it's so tightly bound to these tissues. But it's not supposed to be there, and it occurs during states of insufficiency of calcium, zinc, and even iron. Now, lead is a heavy metal, and it's a common replacement for calcium, and it's readily available in our technological environment. So this compensation is important to consider because just like fluoride, which is another common treatment for osteoporosis, lead can artificially cause our bones to appear more dense. So it looks more dense when you do a scan. But these replacements are actually the body's less preferred element, and they're not as strong as calcium is. And this can also have an effect on that bone mineral density scan, making them appear normal when really there's a compensation that's occurred. And the bones themselves are much more brittle than if it did contain that preferred element, which would be calcium, magnesium, phosphorus, and these kind of things. This compensation, in addition to the depletion and the porous effects of calcium of the deficiencies of these nutrients, it contributes to weak bones, which are typically seen as normal signs of aging, but in my opinion are somewhat preventable, or at least they can be slowed down by getting adequate nutrient intake. Now, I believe that the body is intelligent, and our homeostatic mechanisms are guided by the vital life force. And this is the guiding philosophy in natural medicine, which is what hair tissue mineral analysis and mineral balancing is a part of. The worst effect of bone depletion still occurs when you have inadequate intake. But if you provide enough nutrients, it can slow the rate of these compensations. And it's actually good that they occur, rather than looking at this as all bad. It's actually really good that there's this compensation that happens, because if they didn't happen, when we had prolonged deficiency, we would, or like chronic deficiency states, our skeleton would just kind of keep getting taken away from, to the point when we would just kind of end up like a little puddle, kind of like our wicked witch here in this slide, because we would not have that skeletal structure anymore, so we wouldn't have that ability to stand upright. And this is also why even bone mineral density scans are inaccurate, because the representations of calcium status, because the bone can be very dense but very brittle. Now, I have shown an X-ray here which demonstrates lead accumulation in the metaphyseal as a result of a compensation that occurred from a lack of, zinc, calcium, or iron, or even the overexposure of lead. And that lead eventually gets deposited in the bone, and you can visually see it on this X-ray. Lead is typically deposited near the locations where collagen would be present, and this can also have a negative effect on our joints and even our connective tissues and ligaments. And this is also one reason why a lot of those nutrients that are good for collagen synthesis can be helpful for, improving situations involved with lead excess or lead burdens. So what can we do about this depletion of bone and this compensation that occurs? Well, we need to make sure that we're getting enough of it to prevent the compensations that happen, right? We need to make sure we're getting enough calcium to either stop the compensations of lead, to block the intestinal absorption of things like aluminium. We need to lower that parathyroid hormone to slow down the calcification and reap the benefits of calcium rather than reaping its wrath. But before we get into, solving the problem, we need to cover something else called the therapeutic order. Now, the therapeutic order is one of the core principles of mineral balancing science. It's this hierarchical structure, and it's the ideal approach to all health conditions to minimize both risk and expense for our clients. It is quite logical, but many people just simply overlook it. And if you explain it to them, they go, oh, that makes sense. But it always gets overlooked. So we all know that you should never just start at symptomatic therapies or surgeries or even drug therapy. But, a lot of people do. And if you do, you will not be addressing the root of the health condition. So we must first start at the first tier of this therapeutic order, which is, the foundations, which is, of course, establishing the foundations for health. This is things like addressing lifestyle, environment, diet, and nutrition. We need to remove disturbing factors. Diet and nutrition is important as far as this conversation in this presentation, and we need to keep in mind that diet and nutrition are not the same thing, even though it's often assumed to be. Now, diet is the food that we eat, while nutrition is the nutrients that are in the food, nutrients that are found in our diet. And it's very possible to have a good diet that is nutritionally poor. And if we apply this therapeutic order to our supplement programs, we also must consider that we need to look at reaching the bare minimum requirements of our bodies, which is something called the RDA or the RDI, depending what country you live in. This is the foundational nutritional requirement, and all mineral balancing programs should reach this number minimally. We also need to address the relative deficiencies as well. Now, the RDI, the recommended daily intake, or in the United States, this is called the RDA, recommended daily allowance. They're the same thing. Different countries call things differently, and it gets confusing for that reason alone. But these numbers are derived from something called the nutrient reference values. At least in Australia, that's what we call them. And these are based on the concept of nutritional adequacy, but we need to consider how we define things like adequate. It's nutritionally adequate. I'll use these abbreviations of the RDI and the RDA. I'll use both of them when I go forward, depending on whether this information is sourced from the American National Institute of Health or the National Health and Research Council of Australia, just so that you can always find what I'm talking about by these links below. Now, the recommended daily intake is the average daily dietary intake level that is sufficient to meet the nutrient requirements of nearly all healthy individuals in a particular life stage and gender group. Now, notice that it says healthy people. When we're working with a lot of our clients, we're usually working with healthy people. We're usually working with people that have 1, 2, 3, 10 different health conditions. So these numbers really aren't our goal post. They are merely our starting line. And nutritional adequacy basically just means to prevent an overt or a primary deficiency that results in not getting these RDIs. And this RDI has value, especially to prevent deficiencies in healthy people, but it doesn't ensure that we're getting adequate nutrition for our clients or ourselves that have various health conditions, especially over a prolonged period of time. Just because this can start, the RDI or the RDA can stop a in the moment deficiency, doesn't mean that it's going to prevent a lot of health conditions from occurring later on in life. Now, when the RDI can't be determined, we go by something called the adequate intake. It's adequate. This adequacy is... Anyway, it's used when the RDI can't be determined. You'll find this with something like potassium. There's no real RDI, there's the AI, and that number can vary from country to country. Now, this is defined as the average daily nutrient intake level based on observed or experimentally determined or approximations or estimates of nutrient intake by a group or groups of apparently healthy people that are assumed to be adequate. So this isn't a very scientific method to go by the AI. And even the RDI is not very scientific, but that's for something completely for a different conversation. Now we have this upper limit of intake. And the upper limit, the UL, is the highest average daily nutrient intake level that's likely to pose no adverse health effects to almost all individuals. As intake increases above the upper limit, there's a potential risk for adverse effect, and it increases the higher you go above it. So in general, especially if you're not working with a practitioner, it's always a good idea to be a little higher than the RDI, but try to be a little lower than that upper limit. Of course, in different fields of nutritional medicine, we go way over the upper limit, but as a general safety thing, that's what the government's outlined. Now, there are two different types of deficiencies of a nutrient. There's these things called primary deficiency and a secondary deficiency. Now, primary calcium deficiency is basically just the result of not getting enough through your diet. It's most common in individuals that have increased calcium requirements, like those that are still developing their bones, children's and adolescents, but also for pregnant and lactating women because they're trying to develop the skeleton for someone else, or producing milk, which has calcium in it. And therefore, if you're not getting enough, where do you think that's calcium's coming from, right? Postmenopausal women, people that are experiencing rapid weight loss, and those on total parental nutrition. Fat cells that have more calcium in them can be burned quicker. So it's a good idea on anyone that you're trying to help with weight loss is to ensure that they have a good calcium intake. And this should be prime importance, especially in that situation. And then there's also the secondary deficiency. And a secondary deficiency is a deficiency that's caused by factors that increase the requirement of a nutrient. Too much magnesium, too much potassium, too much of something can cause a relative deficiency of the other nutrient. And that's called a secondary deficiency. This is also quite common, in health conditions that have that are negatively affected by absorption, right? So achlorhydria is basically a lack of HCl production in the body or in the stomach. Most common in elderly, but the more you work with people that are in adrenal insufficiency and low sodium potassium levels on a hair test, even in that NAK inversion, they're going to have really low hydrochloric acid function, so they have impaired ability to absorb calcium. Intestinal inflammation or any malabsorption disorder, these things all can affect your calcium, especially steatorrhea, which excess fat in the stool can also cause the secondary deficiency of calcium. Other things are like factors that affect calcium. So like a compromised vitamin D status can affect your cause a secondary deficiency. Too much vitamin D can definitely cause an issue. When you're low in vitamin D, the body is not able to absorb calcium as well, and thus the PTH increases, the parathyroid hormone increases, and it creates that state of secondary hyperparathyroidism that we talked about earlier. If you can't really rely on the calcium levels that are in blood, or you can't rely on the bone mineral density, and you can't really rely on the HTMA for a calcium level, what do you do? Basically, as much as we don't really like symptoms in HTMA and mineral balancing science, it's actually one of the best things to, especially with calcium, is to have a look at the symptoms that your clients are presenting with, or even yourself. Now, William Koch described what happens when you remove a parathyroid gland from an animal, and it has many of these symptoms. Things like angina or allergies, muscle tightness, heart palpitations, POTS, right? Tetany, clenched teeth, bone pain, thyroid imbalances, and insomnia. Now, the most common signs of an overt or a primary, like a blatant deficiency of calcium is, at least to me, is insomnia. When my clients come to me and they have insomnia, to me, especially if they're taking lots of magnesium, it means they need more calcium. Another common one, osteopenia. If they have depletion in the bone, osteopenia, osteoporosis, big indication that the body's got that elevated PTH and we need to correct that calcium deficiency. When these health conditions are all present, you should always consider calcium supplementation. If you have tinnitus or ringing in the ears or postural orthostatic tachycardia, otherwise known as POTS, it's important to consider that these are often the result of bone depletion. When calcium is pulled from the bones, muscles can put pressure on the nerves, and it puts pressure on the nerves that go from the brain to the ears or to the mouth or wherever, anywhere really along the spine, and this can contribute to some weird behavior. Well, most people consider electrolyte imbalances with POTS, you should definitely consider bone depletion. I found in my practice especially, you really work on increasing bone health, POTS can, just normalize. Now, we must also consider that in addition to primary deficiencies, we can have secondary deficiencies, things like a low calcium to magnesium ratio or a low calcium to phosphorus ratio. A high phosphorus content in the diet and tissues is a common cause for hypertension or high blood pressure. And you can correct this either by lowering the phosphorus intake or increasing the calcium intake. Well, in contrast, we usually find, those slow oxidizers, especially with that high calcium to phosphorus ratio, to have hypotension, very low blood pressure. And this can be improved by correcting that ratio. But you don't necessarily have to increase the phosphorus intake to do it. All right, so when a person struggles with an elevated calcium on an HTMA, they often have signs and symptoms of both excess and deficiency. Now, this is because there's localized excesses and localized deficiencies that are present. For example, the tissues can be calcified, but the blood can still be low, creating the need for PTH, and then the cascade exacerbates because there's a lack of magnesium and all those sodium, potassium to keep calcium in an ionic state. So low calcium to magnesium can have many of the same signs and symptoms as an elevated calcium to magnesium ratio. But in these instances, it is the relatively low nutrient which plays an important role. For example, you can have a tetany or muscle spasms from a magnesium deficiency and a relative calcium excess, as well as muscle spasms as a result of a low calcium relative to magnesium. It's very common these days to assume that everyone has muscle spasms because of a result of magnesium deficiency. That's what everyone says at the markets when they're selling it. But in actuality, any electrolyte imbalance can contribute to these conditions. Not just a magnesium deficiency, not just calcium, sodium, potassium, even phosphorus to some degree. So the electrolytes in general need to be in balance. And there's no one mineral that can correct this situation. And especially because of biological individuality and the person's tissue status, the solution for one person that might have some of these symptoms might be different than the solution for someone else. That's why it's important to work with a practitioner that understands what they're doing. If you want to have a look at these signs and symptoms, these lists and the charts that I'll show next are available on our website at mineralbalancing.org. Our calcium article. So calcium is an essential nutrient, and this means that it must be obtained from the diet. By essential, we don't just mean that it's important. Oh yeah, it's essential, you should have it in your pantry. It means that without this essential nutrient, your body will not be able to function properly. And if the body and the cells cannot function properly, health conditions arise. Now, while many tote, magnesium influences 463 genes, and zinc influences 83, well, calcium influences over 1,000. So clearly calcium is quite important in the body. And since plants and animals can't make minerals, this means that we must obtain all essential nutrients from our environment. So it's a good thing that there's so much calcium available in the Earth's crust. Plants and animals, they accumulate this calcium and other nutrients into their tissues, and as we eat them in our diets, they provide important nutrition so that we can support and promote healthy function of our cells. Now remember, as we are made of cells, and cells combined make up tissues make up organs and glands, and that makes a human. it's important to nourish our cells. So cellular nutrition is very important, and that's what we do with HTMA. Now, if we have a look at this list of RDAs, we can see that, that there's a certain amount that we require. And if you do not get enough, this is the bare minimum, remember, the RDA, bare minimum, the amount that you need to prevent a nutritional deficiency in 98% of healthy people, then what's going to happen is that your body will simply just make up this insufficiency by taking it from its reservoir, which is our bones. So if you have a look at this table, you can see that the RDA for calcium does not really change much from the ages of 4 all the way up to 70. The minimum calcium requirements are somewhere between 1,000 and about 1,300 milligrams of calcium each day that is required. Many individuals aren't consuming enough calcium to meet these minimum daily requirements. And this is especially true in those that are dairy-free or plant-based, such as vegans. The RDA for calcium has been revised a few times over the years, and they keep raising the RDA up. And it seems like this trend will just keep continuing in the future. And this makes a lot of sense to me because quite persuasive evidence that human beings we naturally adapted to high calcium intakes because of our environment. And that the diet of Paleolithic human or Stone Age human, their diet has been estimated to contain somewhere between 2,000 to 3,000 milligrams of calcium each day, which is twice the median calcium intake that's present in most US adults. Now, because of this relative abundance of calcium, the human digestive system has an absorptive barrier to calcium, and we typically only absorb, on average, about 25 to 30% of the calcium that we consume. Now, even when absorption is at its maximum because of a deficiency state, at most the body will only absorb 50% of calcium. And this is because we were getting much more of it in our diet, 35,000 to 10,000 years ago, up until the agricultural revolution, the cultivation of wheat, which, interestingly, it has many components which are antagonistic to calcium. I personally think that we should try and get more than the RDA of all nutrients, calcium included. So I feel that when we're aiming for calcium, for an intake of calcium, I think that looking at 2,000 to 3,000 milligrams each day is optimal, and it mimics what we would have gotten in our Paleolithic era. This table here is readily available to anyone for free on the National Institute of Health's website. All right, so let's keep going about calcium absorption. So consuming the RDA of calcium, just because you get it in you doesn't mean that you can absorb it all. And when calcium is found in the diet or a supplement, it's usually found in a salt form, which must be released from this salt in order for absorption to occur. So since we adapted to this high calcium environment, absorption is generally quite low. And it can be even lower for those that have compromised hydrochloric acid production in the stomach. Now, the Na and K levels, sodium and potassium levels on an HTMA reflect our body's ability to make hydrochloric acid. And hydrochloric acid is very important for these calcium ions to become soluble. When there's a lack of hydrochloric acid, the calcium salts enter the small intestine, which has a higher pH environment, where they're more likely to precipitate and be rendered unusable. Now, if the small intestinal conditions aren't ideal, the next stop would be to go through the large intestine, where the body's only going to absorb about 4% of the calcium that's present. And it's often said as you get older, that your calcium absorption diminishes. And this has to do with, vitamin D receptors, but also a person's hydrochloric acid functionality in the stomach, among other reasons. They also typically don't consume enough. So in HTMA, we commonly find that when a person has a high tissue calcium, they also often have low sodium and potassium levels, which indicates this low HCl production. And when HCl is low, the calcium that is consumed from the diet is not really biologically available or bioavailable for use. Now, in my opinion, the cause for a high calcium level on an HTMA is actually the decreased adrenal gland function to begin with, which sets the whole PTH cascade that I mentioned earlier, and then it causes biounavailability of copper, and that to me is really why we get this high level of calcium. But the calcium found in both food and supplements vary quite substantially. And the bioavailability is also affected by digestive issues such as compromised digestive health, phytates, oxalates, fiber, unabsorbed fatty acids, and other divalent minerals that people might be supplementing that can be antagonistic to the absorption of calcium. So the obvious solution would be to seek out more calcium from the diet or supplements to provide a more bioavailable form of calcium, while focusing on increasing the HCl production so that you can improve the absorption of calcium in the long run to calm that parathyroid down. Now, this is the reason why I like to give all slow oxidizers betaine HCl supplements. It not only helps them lower their tissue calcium, but it gets to one of the roots of the issues, the malabsorption of calcium. Now, interestingly, just as a side note, carbohydrates and protein and even the presence of vitamin D are known to enhance the uptake of calcium into the body. And the slow oxidizer diet that was developed by Dr. Zek and Dr. Watts does recommend that the slow oxidizer consumes more protein and carbohydrates relative to fat. All right, let's talk a little bit about osteoporosis trends. So today, US adults typically consume only about 1/5 to maybe even 1/3 of as much calcium as did the Paleolithic humans. They get nearly half of the RDA of calcium. And the adaptive mechanisms I outlined earlier involving PTH and vitamin D evolved over time to help Paleolithic humans during breaks in the supply of calcium-rich foods, whether it was due to weather or season. However, the calcium-restricted diets common today force the same mechanism into continuous high gear for most of the adult life. And this has a variety of consequences long term. So when you do not get enough calcium, the parathyroid pulls the calcium from the bones, and in the long term, we develop something called osteopenia or osteoporosis. Now, not everyone will have a diagnosis of osteoporosis, but we all, at least to some degree, are showing bone degradation if you were to have a scan done. And we will all inevitably end up with bone depletion and this diagnosis eventually, because it's seen as a normal sign of aging. So which HTMA trends give us more information about what type of osteoporosis we are likely to develop? Well, according to HTMA science, there are at least 2 different types of osteoporosis. And these ratios can change a little bit throughout your time on a mineral balancing program, but it's what it is on an average over a longer period of time that gives us more information. But the first type is type 1, and it's characterized by having a calcium to phosphorus ratio that's under 2.5 on an HTMA. And this is often found in those fast oxidizers. And they're generally known for having that elevated sodium and potassium levels, which indicate excessive adrenal and thyroid activity. They have difficulty retaining calcium and magnesium. These elements are lost through the urine, and thus they're low tissue calcium and magnesium that we see on the hair test. Now, they also simultaneously retain phosphorus, and this is why the ratio is considered low. They have low calcium relative to phosphorus. The other type of osteoporosis is type 2, which is indicated by the calcium to phosphorus ratio that's over 2.5 on a hair tissue mineral analysis. Now, this is often found in those slow oxidizers that are known for having the low sodium and potassium levels, which indicates underactive adrenal and thyroid activity. Now, in this situation, the parathyroids are working overtime, and rather than the loss of calcium in the urine, the body is now retaining calcium and magnesium to correct the deficiency and decreasing the absorption and even the retention of phosphorus. Now, traditionally, the type 2 pattern in hair tissue mineral analysis wasn't given calcium. And this is currently how Dr. Watts at Trace Elements approaches this pattern to this day. But Dr. Paul Eck also thought, this is how we did it as well. The idea was to make calcium more bioavailable by using potassium, magnesium, and sodium. And eventually, Dr. Eck found that this just didn't work. He abandoned the idea and realized that we need to correct the endocrine imbalance of the parathyroids. We need to provide calcium to correct the dietary deficiency, and that's the best way to calm the overactive parathyroid hormone, and thus lower the effects of parathyroid hormone trying to raise calcium on an HTMA. Now, magnesium and potassium are also really quite helpful for lowering parathyroid hormone to correct that calcium to phosphorus ratio, but it doesn't work as well as calcium. It's the reason parathyroid hormone is released to begin with. Magnesium is also really important parathyroid hormone modulator. It's kind of like a parathyroid adaptogen, and it's that synergistic capacity of magnesium and calcium here. So you can use magnesium to either raise or lower parathyroid hormone. This is why it's given to both patterns as well. Now, there's one common pattern that is sort of a mix between these two types of, type 1 and type 2. And those are those individuals that are in 4 low patterns. They have similarities to type 1 that they usually, not always, but usually have a low calcium to phosphorus ratio. But they're also known for having very low sodium and potassium, just like in the type 2. So when we provide nutritional supplementation for correcting these imbalances, we need to address these 2 types of osteoporosis, these 2 trends for osteoporosis. So I give calcium to both. But what I do differently is to provide a different type of calcium depending on the calcium to phosphorus ratio. Individuals that have a really high calcium to phosphorus ratio, I usually give them a type of calcium that has phosphorus in it. Something like hydroxyapatite or tricalcium phosphate or monocalcium phosphate. Things of this nature. They have phosphorus present, but also calcium. Whereas when I work with those individuals with type 1 or that low calcium to phosphorus, I'm really looking at giving a calcium that doesn't contain phosphorus because we want to raise the calcium. So I like to give, calcium malate or calcium glycinate or, something of this kind that doesn't contain phosphorus to help correct that ratio there. When we do use, if someone was diagnosed with osteoporosis though, and you want to help support and promote healthy bone function, it's also a really good idea to consider still using hydroxyapatite because it's quite an excellent all-around calcium supplement. And this is because it contains trace minerals in it and different components that are important for promoting and supporting healthy bone metabolism. So it's definitely something to consider to at least prevent bone depletion going down the road or to help support a person that's currently experiencing it. Now, the core of mineral balancing is to provide the RDA and balance the body's nutrition. However, the RDA does not consider biochemical individuality. It's just stagnant numbers. And in actuality, the requirements for nutrients depends on many different factors. So when it comes to getting enough calcium, one of the major factors to consider is the relationship between calcium and phosphorus. Now, the total amount of phosphorus consumed affects our calcium requirements. Phosphorus is the name of this element comes from the light bearer or the torch bearer, and its ability to ignite and carry fire. That's how it got its name. Now, in the body, phosphorus is really important for numerous functions. Activates more genes than calcium does. I think it activates more genes than any other element in the body, actually. But most notably, phosphorus is known for its requirement in creating biochemical energy, ATP, adenosine triphosphate. You need to have phosphorus to make biochemical energy. Adenosine triphosphate has 3 phosphate molecules there. And we need to keep in mind that too much phosphorus increases the amount of calcium that we need. Ideally, we should have a ratio of calcium to phosphorus somewhere around 2 to 1. But I like to aim a little bit higher than that. 2.5 to 1 is where I like to sit. And this is because I want to make sure that that there's not going to be a phosphorus excess that creates this parathyroid hormone released and creates that secondary calcium deficiency. It's maybe slightly higher or slightly different depending on your unique situation, but in general, as long as you're maintaining the ideal dietary calcium to phosphorus ratio of 2 or more, you can also increase the phosphorus intake to antagonize an elevated calcium level on a hair test. But you need to keep that calcium to phosphorus ratio that's coming in on the higher amount. It can be very difficult, though, to assess phosphorus intake. So you can use apps, that track the mineral content of food, like Chronometer or something. But it's not really accurate with phosphorus because many companies, especially meat companies, are allowed to add things into the meat called organophosphates as a means of preserving them. And this is often not listed as an ingredient. So because of these organophosphates, you're probably getting more phosphorus in your diet than you think you're getting. So let's talk a little bit about, the calcium to phosphorus ratio of the foods that we eat. Now, just because you consume a food high in calcium doesn't mean you're going to get it. Now, not only is this because of the hydrochloric levels of the body, but also due to the phosphorus content of the food you're eating. The average intake of phosphorus in the US is well above the RDA, while the average calcium intake is well below the RDA. And this is problematic because excessive dietary phosphorus has been associated with adverse effects on bone and mineral metabolism. Now, it's not uncommon, especially in carnivores, to be dairy-free and consume. And these individuals often consume a ratio of 1 calcium to 20 phosphorus because they focus on, meats and muscles. Now, rarely have I ever spoken to carnivores that eat animal bones. I have talked to a few, but rarely. So they consume a lot more phosphorus in their diet. And the more phosphorus rich diet you consume, the more calcium you need to keep that calcium to phosphorus intake in check. Meats can be challenging because, those organic phosphates that are added, so they can be even higher than what I've put in these tables here. Almonds, for example, is a plant, right? It's a seed. It's a nut. And almonds have a lot of calcium in them. But we also need to consider that they can be an important part of helping getting your calcium requirements to meet that RDA through your diet, food first. But the ratio calcium to phosphorus in almonds or even sunflower seeds is lower than that ideal amount we've talked about. And thus, it can further contribute to a relative calcium deficiency. Now, they can still be helpful for the slow oxidizers with a low phosphorus level, but in general, you need to consider balancing this calcium to phosphorus ratio if you do consume these phosphorus-rich foods. So naturally, carnivores need more calcium than omnivores. Meat, nuts, seeds, grains, beans, they all have a high phosphorus level, so the calcium to phosphorus ratio is very low, which isn't ideal for bone health, since these are not great sources of calcium due to the calcium to phosphorus ratio. Even if they have a lot of elemental calcium present, it's antagonistic and still causes that PTH to be released. So if you do eat high phosphorus foods, which is totally fine, you should also consider a food along with it that has a high calcium to phosphorus ratio to help keep things in balance, to keep your calcium to phosphorus ratio in check. Now, having foods regularly that have at least calcium to phosphorus of over 1, the rate of 1 calcium to 1 phosphorus, is pretty great, honestly. I think they're the ideal foods to consume regularly. They're the staples, in my opinion, because they help keep you on this calcium to phosphorus dietary intake that's conducive to at least maintaining bone health. Now, dairy products are, a quite digestible source of calcium, and they have a pretty good level of calcium in them and a pretty decent calcium to phosphorus ratio, which helps keeps that parathyroid hormone low. We should also consider having small, frequent meals and consuming high amounts of the cofactors to lower parathyroid hormones such as magnesium, potassium, calcium, and vitamin D. Niacin, vitamin B3, niacinamide, and vitamin A can also help regulate the phosphorus and calcium balance and help improve the calcium to phosphorus ratio on the hair test. But eating foods high in those that also have an elevated calcium to phosphorus ratio is pretty smart tactic to do as well. Now, the one reason I think milk and dairy products especially have been vilified is because just including milk in your diet is not really effective at correcting a phosphorus dominant diet, since the calcium to phosphorus ratio, as we can see, is 1.5 calcium to 1. It's not going to be a stark contrast to the meat ratios, like pork here, 1 calcium to 36, or sirloin steak, 1 to 17. Calcium doesn't really have enough calcium, or milk doesn't really have enough calcium to counteract that. But I think that's one reason why it kind of gets vilified, saying it doesn't help correct, bone depletion and this kind of stuff. But it can still definitely be a great addition, especially in those plant-based diets, because those plant-based diets actually have their calcium to phosphorus ratio is not too bad, right? Like in compared, the pork is 1 to 36, which is probably the worst. But we can see that the almonds and the sunflowers are not too far out. So milk can be quite helpful at maintaining a good calcium to phosphorus ratio in the diet. And this is probably one reason why lacto-vegetarians, vegetarians who consume milk, are able to get enough calcium in their diet and also meet the RDA, and therefore, they generally don't have compromised bone mineral density. And, it's because they're eating foods that don't have that large deviation of calcium to phosphorus. But vegans, they can theoretically obtain sufficient amounts of calcium intake through diet, but it's impractical because the amount of vegetables that's required is just not something most people are going to consume. So they often have fortified foods, which are basically just supplements, right, to make up the difference in that calcium to phosphorus ratio. Now, as an example of the difficulty of trying to reach the RDA as a vegan, just as a side note, it would require about 4.5 cups of broccoli to equate to a single glass of milk. Now, it's true that calcium in broccoli is more absorbable, even with the calcium to phosphorus ratio that is somewhat low, but even still, drinking milk is a lot more feasible than consuming 4.5 cups of broccoli just to equate the single glass of milk. So to reach the RDA, you'd have to consume 13.5 cups of broccoli a day. And even if you did eat this much cruciferous vegetables, I really like broccoli, but I don't know about you, but I would rather much have, 3 glasses of milk each day than to have 13.5 cups of broccoli. So that's the one, a major challenge there. Another one is that the total amount of oxalates that are found in the food can also block calcium absorption. And another is also the naturally occurring cyanogenic glucosides or the thiocyanates, which can block thyroid hormone production and then still raise calcium in the hair test and lower thyroid function, raising PTH. Another challenge is, the calcium to phosphorus ratio of broccoli is not that great. And, if you were, it's not as good as if you were to consume a food that were to have a better calcium to phosphorus ratio. It'd be a lot easier, but you'd still have that challenge. So like something like collard greens would be a lot better of a food to use than broccoli, but still there's that challenge of oxalates and goitrins, which can still negatively affect the thyroid hormone, etc. Spinach, which is also said to be a really good source of calcium, isn't really. This calcium that's found in spinach is primarily found as a calcium oxalate, which is indigestible. Only 1/3 of the spinach of calcium is available as a source of calcium for us when we eat it. So this actually makes it a much weaker source of calcium than other leafy greens. You can still use it in your diet, but it should be on a minor portion of your diet for this reason, because the oxalates, and then it's not really a good source of calcium either. I still like spinach because it's got a lot of whole food goodies, but it's just not one of those bone nutrients that I like to use, or bone foods. So many of the paradoxes that are found with calcium lead to the myths of calcium. But when you understand that how these paradoxes work, you can see that the complexities of calcium are a result of a lack of understanding of calcium. And in this presentation, we discussed, calcium levels on an HTMA being quite deceiving, and how if it's a high level, a low level, or normal range, or even ideal, all of these can still indicate a requirement for calcium. We also talked about how hydrochloric acid is required to absorb calcium effectively. Talked about how the calcium to phosphorus ratio of the diet is a major factor for improving bone health. And we also talked about how an elevated calcium level is commonly due to a dietary deficiency and an overactive parathyroid hormone and an underactive thyroid function. So they have high parathyroid, low calcitonin. Adrenal insufficiency negatively affects the liver's ability to make ceruloplasmin, which creates biounavailable free copper in the blood, increasing estrogen dominance and inflammation, which the adrenal gland is unable to neutralize due to the low sodium, magnesium, and potassium status. Now, with low amounts of these nutrients, calcium loses its ionic charge and is precipitated into the tissues. And this lowers blood calcium, which signals PTH to take it from the bones, and a cascade occurs quite rapidly, resulting in further tissue calcification. So maintaining ionic blood calcium levels with supplementation and/or diet, in addition to a mineral balancing program and using other nutrients, is necessary to correct the root cause, not just calcium or any other isolated nutrient. Nutrients work as teammates, so we need to provide the cofactors together. A low calcium level is usually due to an excessive adrenal gland activity and an overactive thyroid gland. An excessive adrenal gland activity increases copper requirements as well as calcium because it's being lost through the urine. So the person with a low calcium level generally has a lower PTH and a very high calcitonin, but they still have bone depletion. It's just relatively, there's a lot more calcitonin to keep the levels low. So when we're supplementing with calcium, we need to consider increasing the calcium intake to at least the RDA. We can go a little bit higher, 2,000 to 3,000 milligrams. What you need to balance that calcium to phosphorus ratio of the diet, and focus on that calcium to phosphorus ratio of the diet to keep it at least 2.1 or a little bit greater than that. Slow oxidizers, we like to give them a calcium supplement that contains phosphate or phosphorus, and fast oxidizers require a calcium supplement that doesn't contain phosphate. The best form of calcium for building bones is hydroxyapatite, although you must use this in addition to a mineral balancing program and not just by itself. So thanks for watching the HTMA Virtual Summit. If you're interested in learning more about minerals and HTMA science, don't forget to check out my website, mineralbalancing.org. If you like science-based information regarding vitamins and minerals, regularly check out our blog posts where I write articles on all things mineral balancing and HTMA. Also stay tuned for the Mineral Balancing Academy, the most in-depth education platform for learning about HTMA and minerals. Our course features over 100 hours of content, has live discussions, Q&A, and even case studies. You can expect that to be officially launched somewhere around the end of 2022. I don't foresee it anytime sooner. It'll be definitely at the end of 2022, maybe the early 2023. Lastly, if you really resonated with what I've spoken today and would like to work together, please reach out through our contact page at mineralbalancing.org. Bye for now.